y equal to x, and then you pick 2 points P and Q, x1, y1, x2, y2. To get the gradient of this line, you say change in y over change in x, which is y2 minus y1 over x2 minus x1. That is how we get gradient over a straight line. Now, what about gradient over a curve? Y, x. Now we have a curve, y equal to x squared. Then we have our P and Q. This one is x, and the y coordinate will be x squared. The x coordinate x plus h, the y coordinate x plus h squared. That is if the distance between the 2 points is h. So the gradient will be gradient, again change in y over change in x, which is x plus h squared minus x squared over x plus h minus x, which is going to be x squared plus 2xh plus h squared using quadratic identities minus x squared all over h, which is definitely going to be x squared plus 2x when you divide, of course, x squared minus x squared will be 0, so you remain with the 2x remain with 2x, divided by h would be 2xh divided by h is 2x, h squared divided by h is h, 2x plus h. But you see, for a curve, the gradient of a curve is not the same at different points. The gradient keeps changing, and therefore what we want to do is to reduce P and Q, or to bring together P and Q. Or in other words, we reduce h to 0. So we say as h tends to 0, so that we only focus at gradient at one point, which now becomes 2x. Because when h tends to 0, the gradient function becomes 2x. What if we have another curve? What if we have another curve? Y equal to x cubed. We will have our 2 points P and Q. This one will be x, and this one will be x cubed. This one will be x plus h cubed. And therefore gradient equal to change in y over change in x, which is equal to x plus h cubed minus x cubed all over x plus h minus x, which is going to be x. We use binomial expansion, so we need coefficients. They are in the maths table, but you can generate them by just saying 1, 1, 1, 2, 1, 1, 3, 3, 1, 1. Therefore, it's going to be x cubed plus 3 x squared h plus 3x h squared plus h cubed minus x cubed for the numerator over h, because that is x minus x, you get h. X cubed minus x cubed is 0, so you remain with 3x squared plus 3x h squared plus h cubed divided by h. And when you divide h throughout, no, this is 3x squared h. So when you divide h throughout, it becomes 3x squared plus 3xh plus h squared. As h tends to 0, it actually becomes 3x squared, because this one will be 0 and that will be 0. Now, what if we try another one? What if we try another one? X. What if we try another curve, y equal to x power 4. We have our 2 points P, Q. This is x power 4. This is x plus h power 4. And therefore gradient equal to change in y over change in x, which is x plus h power 4 minus x power 4 divided by x plus h minus x, which is going to be, we use binomial coefficients. We had 1, 3, 3, 1. We can add there 1, 1, 4, 6, 4, 1. So it will be x power 4 plus 4x power 3h plus 6x squared h squared plus 4x h cubed plus h power 4 minus x power 4 divided by h, which is going to be x power 4 minus x power 4, 0. 4x cubed h plus 6x squared h squared plus 4x h cubed plus h power 4 divided by h. And when you divide h, you get 4x cubed plus 6x squared h plus 4x h squared plus h power 3. But as h tends to 0, it becomes 4x power 3, because this one will be 0, 0, 0. So this is the conclusion that we can make in form of a table. We write function and then the derivative over the gradient function. The derivative is the gradient function. So let's have a table of function, then the derivative. The first one was y is equal to x. Of course, this one, the gradient is 1. The second one was y equal to x squared, and we found the gradient function as 2x. The third one was y equal to x cubed, and we found it as 3x squared. Then y equal to x4, and we found it as 4x cubed. And then I may add another one, y equal to x5. And finally, the general formula, y equal to x power n. So y equal to x power 5, what do you think it will be? As you can see, there's a pattern here that the power, the index reduces by 1. this was 2, it is 1. This was 3, it is 2. This was 4, it is 3. So the index reduces by 1. And the coefficient of x squared here, the coefficient here is equal to the index. The coefficient is equal to the index. So that means this one will be, you start with the coefficient which is equal to the index, which is, 5. And then x, and then the index reduces by 1. So what does that mean? It means y equal to n a n minus 1.